Okay, in this last video for this section, I'm going to walk you through one more example of a sample size question for a proportion. A recent study indicated that 29% of the 100 women over age 55 in the study were widows. Two-part question. Part A, how large a sample must you take to be 90% confident that the estimate is within 0.05 of the true proportion of women over age 55 who are widows? And then in part B, if no estimate of the sample proportion is available, that if we did not have that recent study that gave us that 29% figure, then how large should the sample be? Okay, part A, we do have a number for p hat. It's 29% or 0.29. Q hat is always 1 minus whatever p hat is. So 1 minus 0.29 would be 0.71. If 29% of them were widows, the other 71% were not. For 90% confidence, the number we use for z sub alpha over 2 is 1.65. And we want our estimate to be within 0.05 or 5%. So the number we put in for E is 0.05. So let's calculate all that. 0.29 times 0.71 times, in parentheses, 1.65 divided by 0.05, close parentheses, squared, and that came out as 224 point something, so we round up to 225. You need to go out and get a sample of at least 225 women over age 55. And then for part B, that's where we don't have that 29% figure, so we put in 0.5 for p hat times 0.5 for q hat times 1.65 over 0.05 in parentheses squared. 272 point something rounds up to 273. So the sample should have at least 273 women in it. And these sample sizes that we're getting are fairly large. And that's pretty typical. It turns out that you usually need a significantly larger sample to estimate a proportion than you do to estimate a mean. So when we were doing sample sizes for means, we use that formula for that. We got whatever we got. Here we're getting numbers that are mostly pretty big, and that can happen. You might need a pretty big sample if you're trying to estimate a proportion to within 5% or 3% or 2% or something close like that.